We are looking at R.D. Sharma's solution, class 12th, chapter 7, adjoint and inverse of a matrix. Exercise is 7.2. Find the inverse by using elementary row transformations. Now here, there are various ways to find out the inverse. For example, if we call A, then the A inverse is simply when you multiply these two, you'll get the identity matrix. And when you multiply A with any value, it gives you I, then that value, that X, is nothing but the inverse. For example, if you multiply both sides by A inverse A will be identity matrix, and on the right hand side you get A inverse into I. Again, it will be A inverse only, and multiply anything with I, it will be X. So the inverse, this is the way we compute the inverse. But there are other methods also. For example, we have the elementary row transformation. So in this elementary row transformation, what we do is, we have a matrix and we purposefully multiply this with identity matrix, and we know that multiplying any matrix with the identity matrix is going to give that same matrix back, right? So A will be equal to identity matrix into the A matrix or any matrix. When you convert this A matrix in any way to identity matrix, that means the conversion meanwhile for this I, on the right hand side this I, will be A inverse, because you can only get an inverse when you multiply the number with the value with its inverse value. For example, A multiplied by A inverse will only give you I. So the whole idea is that we write A equals IA, then we make this left A as I, because A into A inverse is identity matrix. On right hand side, the I has to become the inverse by the theory and by the discussion of all the adjoint matrix. All this we have done up till now. So we'll start with this. A equals IA we have to do. This is what the thing you have to do in 2 by 2, 3 by 3, all the matrix. So I'm writing this A matrix. It's 7, 1, 4, minus 3. I'm writing the identity matrix here. So 1, 0, 0, 1. This matrix will be the inverse matrix after we complete all the row transformation. And on the right hand side we write A, that is the multiplication with A. So whatever changes we do on the left hand side, the same transformation, same row transformation will be carried out on the right hand side, left and right, both ways. So our intention is to make this left hand side matrix, A matrix, as the identity matrix. There are 2 rows and 2 columns. So we can either perform the elementary row transformation, we can perform elementary column transformation, but we will try to do only the elementary row transformation. So here we need this identity matrix. 7 will be 1, minus 3 will be 1. So first we will do row 1 will change and multiply it by 1 by 7, because we need 7 as 1. We are trying to make this matrix as identity matrix. So what you do, the whole row, left hand side, right hand side, the first row has to be multiplied by 1 by 7. So 7 by 7 is 1. This is 1 by 7. This will remain like this for negative 3. And on the right hand side, again the first row has to be multiplied by 1 by 7. So 1 by 7, 0 into something is 0, 0, 1. Now one of the value we have got. Now we'll make this 4 as 0. So row 2 will change, row 2 minus 4 into row 1. Because if you multiply this row 1 with 4, you'll get a 4. And you subtract it with row 2, so 4 minus 4 is going to be 0. So essentially the column, the diagonal will have to be 1, others will be 0. So we are making 1 more as 0. So 4 minus 4 into 1 is 0. Minus 3 minus 4 into 1 by 7. So that is going to give you what value? Because that will be minus 25 by 7. How this is coming? I'll just show you, because actually we are going to add it, because we are subtracting minus 3 minus 4 by 7. So we'll take a negative outside, and it will be simply 3 plus 4 by 7. 7 3 is 21, 7 3 is this 7 3 is 21, 21 plus 4 is 25, 25 by 7. And since we have taken negative outside, this I am doing it right now. So this is 3 by 1, 7 3s are 21, 21 plus 4 by 7, that is 25 by 7, right? Negative 25 by 7. So we have 1 and 0. We still need, and this has to be done on the right hand side also. 0 minus 4 by 7. So minus 4 by 7. 1 minus 4 into 0. It will not change. It will remain as 1 only. Okay. That A is, continuing. I am not writing, it is continuing. So 1 and 0 has come. Let us make one more 1. This minus 25 by 7 has to be made as 1. But remember, whenever you are doing any kind of transformation, the 1 and 0 which you already made should not change. So we will multiply the row 2, because it is minus 25 by 7. If you multiply it by minus 7 by 25, minus minus will be plus, 25 gets cancelled, 7 gets cancelled, you get 1. So whole of the second row, that is row 2 we are multiplying. It's not row 3, it's row 2. There is a slight correction. Row 2 will multiply by minus 7 by 25. So you multiply 0 by minus 7 by 25. First row will remain like that. 1 by 7. This is going to be 0. Minus 25 by 7 multiplied by minus 7 by 25 is going to be 1. Just because we wanted this to be 1, that is why we did all these things. So first row will remain like that. 1 by 7, 0. And now we multiply minus 4 by 7 by minus 7 by 25. So minus 4 by 7 into minus 7 by 25. Minus minus becomes plus. 7 gets cancelled. It's going to be 4 by 25. And then this 1 multiplied by minus 7 by 25, it is going to be negative 7 by 25. Okay, one more thing is remaining. 1 by 7 has to be made as 0. So what we'll do is, we'll multiply this row 2 by 1 by 7 and we'll subtract it from R1, row 1. So you might be questioning why we are not multiplying this whole row by 7, because 1 by 7 will be 1. But we don't need a 1, we need a 0. And 0 can only be obtained when you use this 1 below 1 by 7. So 1 by 7, if you subtract by 1 by 7, you get 0. You have to multiply this 1 by 1 by 7 and then subtract it with 1 by 7. So whole thing is, row 1 we are changing to row 1 minus 1 by 7 into row 2. Okay. So what do you get finally? This finally I am doing. Row 1. So this we are executing. So we get 1. This see. Row 1 minus 0 into minus 1 by 7, it won't affect. That is going to be 1. But the second thing which we actually wanted to become 0, 1 by 7 minus 1 into 1 by 7, and that is going to be 0. 1 by 7 minus 1 into 1 by 7, that is going to be 0. Now this also gets changed. 1 by 7, 4 by 25 minus. So row 1 minus 1 by 7 minus 4 by 25 into 1 by 7. And let me write the final one. This computation I hope you will be able to do. So this final will be, this is going to be 4 by 25. 1 by 7 will become 3 by 25. And this again R1 minus 1 by 7 into R2, this is going to be 1 by 25. So 3 by 25, 1 by 25 the first row, 4 by 25 minus 7 by 25 second row. This is going to be your A inverse. Because whatever you are doing on the left hand side, you have to perform it on the right hand side as well. Right? So this is the final identity value. And this is A. So what should be here? It should be A inverse. So this is final A inverse. This is going to be your A inverse. I hope you got the idea. So final value I am writing again. 3 by 25, 1 by 25, 4 by 25 and minus 7 by 25. This is your A inverse. So there are multiple questions exactly like this. I'm just going through this. I'm not going to do that thing, but I'm just proceeding. Okay. So A equals I into A. Same thing here. We have to make this one diagonal as 1 1 and other values as 0 0. A equals IA we are going to perform. So finally the right hand, when you make this left hand side A as identity, right hand side I will become the A inverse. So all these questions which are following are exactly similar. So I am just giving you a hint here and showing you the actual result. Whenever you are doing it by yourself, you can just have a glimpse here and see the answer if you need to. Same thing. This is all because of, the multiple questions are just because you need practice. Find the inverse by using elementary row transformation. So this is a 3 by 3 matrix and we'll apply the elementary row transformation and then we'll try to find out the inverse of this matrix. So we have A equals I into A. Identity matrix, when you multiply it with any matrix, that is going to come as the same matrix. So even if you write A equals IA, it won't affect. They both are equal actually. Solution is in front of you. But we are going to do this example one by one, step by step, so that you understand fully how this elementary row transformation work in case of finding out the inverse of the matrix. So you have 0, 1, 2 here, 1, 2, 3 and 3, 1, 1. This is your A, the matrix. Then identity matrix here. Because A we are going to essentially make the left hand side A as I. So that I we are starting with it. So we have this identity matrix. This is called I3 also, I subscript 3 also. And this A will of course come, but I am not writing it. The right hand side A multiplied by A. So basically we have to convert this left hand side so that it becomes the identity matrix. And meanwhile, while doing all these steps, the right hand side will become the A inverse. So row 2 we are changing to row 2 minus row 3. Why we are doing this? Just because we want the diagonal values as 1, other values as 0. So row 2 minus row 3, see 1 minus 0, the first row and the third row will remain like that. So let me write the first and third row, it won't change. So row 2 minus row 3. So 1, row 2 minus row 3, okay, 1 minus 3 minus 2, 2 minus 1, 1, 3 minus 1 is 2. And third row will remain like that. So I'm just write, this also you have to do, okay. Row 2 minus row 3, 0 minus 0, 0, 1 minus 0 is 1 and 0 minus 1 is minus 1. So this row 2, I'll just add negative 1 here. So I'm adding it, minus 1. I'm just trying to suggest whatever row transformation you will do, you have to do it simultaneously on both the matrix on the left hand side and right hand side. Okay, so we have got 2 ones in the diagonal, one more one will do. So we will change row 1 to row 1 minus row 3. Sometimes we do this row transformation twice or thrice so that we prepare the matrix for next 0 or 1. So row 1 minus row 3 is 0 minus 3 is minus 3, 1 minus 1 0, 2 minus 1 is 1. Other I am just writing like that. So 1 minus 0 is 1, 0 minus 0 is 0, 0 minus 1 is negative 1. And this is 0, 1, negative 1, 0, 0, 1. Okay. So this, why we have got this minus 3, you will just see. When we add this first and third row, we will get certain value. So row 3 I am changing, row 3 plus row 1, because 3 minus 3 is going to 0. It is going to be 0. So we'll get one more 0 here. So just see here, we are adding the third row to the first row. and other row will remain unchanged. So in all these processes, just write those rows first which are not going to change. For example, -3, 0, 1, -2, 1, 2, and then row 3 will be row 3 plus row 1. So 3 minus 3 is 0, 1, 1. We are adding, sorry, 1 plus 0 is 1 and 1 plus 1 is 2. Row 3 only will get only change. 1, 0, -1, 0, 1, -1, and 0 plus 1 is 1, 0 plus 0, 0, 1 minus 1 is 0. So we have got around 2 zeros, and we still need to work upon it. Since we have a 3 and a 2, now we can perform a row 2 change, because -2 and 2 we are able to see that. So we'll do what? We'll change the row 2 such that we'll multiply row 2 with 3. If you multiply row 2 with 3, you multiply this row 1 with 2, what do you get? 6 and 6, both negative, and then you can subtract. So we are changing row 2 to thrice of row 2 minus 2 twice of row 1. Okay, so -2, we are multiplying it with 3, so -6 you'll get, and we'll subtract it twice of row 1, 2 into 3, 6, and since it is negative, it is going to be -6. This is going to be 6. Okay, so -6 plus 6 is going to be 0. So we wanted it to be 0. That's why we did this. I have taken a whole process, kind of example, so that you know every row transformation what we are doing. So the first row will remain unchanged. So thrice of row 2 minus twice of row 1. What do you get? 6 minus 6, 0. Then thrice of row 2, 3. 3 into row 2 minus 2 into 0. That is going to be 0. So what do you get here? You get a 3 here. 2. Thrice of 2 is 6, and 6 minus twice of 1. So you get 4 here. And rest will be like this, 0, 1, 2. Same thing you have to do here. 0, 1 minus 1, 1, 0, 0, that will remain unchanged. Now multiply this with 3. 3 into 0 is going to be 0 only. Minus twice of R1. So it is going to be -2. 1 into 3, that is going to be 3. 3 minus 2 into 0, that is going to be 3 only. -1 into 3 is -3. Minus twice of R1. So -3 and minus, because it is minus, so plus 2. So it is going to be -1 here. Okay. So see, this row transformation takes some time. It takes, I must say that it takes a lot of time. That is why we adopt the other methodology to solve the A inverse. But still, you may be asked about this. Now next one is R3. We are changing to R3 minus R2. Row 3 only will be changed, and that will be changed by subtracting row 3 with row 2. So 0 minus -3 is 3, 1 minus 0 is 1, and 2 minus 1 is 1, because we need a 1 in the diagonal. That is what we are doing. We need 1 in the diagonal and other values as to be 0 on the left hand side. Okay. So R3 will be changed to R3 minus R2. So I'll just write it here, and that, please remember, that has to be done on the right hand side also. Same thing what is on the left hand side should be on the right hand side. So -3, 0, 1, 0, 3, 4, R3 minus R2. So 0 minus of -3 is 0 minus -3. So R3 minus R2, 0 minus 0 is 0, 1 minus 3 is -2, and 2 minus 4 is -2. Here also, this first and second row you can just write like that. 1, 0 minus 1, -2, 3 minus 1. Then 1 minus of -2 is going to be 3. And 0 minus 3 is going to be -3. And 0 minus of -1 is going to be 1. So -2, now there is in your row 3. So let us change this row 3. Let us try to make it as 0 and 1s. So we will multiply row 3 with minus 1 by 2. So all minus 2 will be gone. We can get rid of them. So I'll just change the color, and it is minus 3, 0, 1, 0, 3, 4, and multiply this by negative half. So that is going to be 0, minus 2 into negative half will be going to be 1, and this is also 1. And this 1, 0, minus 1, minus 2, 3, minus 1, minus half. So it is going to be minus half is minus 3 by 2. This also minus, since it is minus plus 3 by 2, and you have minus 1 by 2. Okay. Now we'll change row 2 to row 2 minus 4 into row 3. Row 2 we are changing. Only row 2 will change, and row 2 will be changed to row 2 minus 4 row 3. So minus 3, 0, 1 will remain like this. And this 0, 1, 1 will remain like this. Those rows which are not changing, just write it like that. Otherwise there will be a confusion. So just write those which are not changing. So I am writing all it here. And row 2 we are changing, row 2 minus 4 into row 3. So 0, 0 minus 4 into 0. 3 minus 4 into row 3. 4 into 1. It is going to be negative 1. Then 4 minus, specifically for this we have done this. 4 minus 4 of R3, this is going to be 0, sorry. Same thing we are going to do on the right hand side. So I am just writing it. I hope you'll be able to do that. So I am just writing the values here, because that thing has to be done in say same way as the left hand one. Now R3 we are changing to R3 plus R2. R3. So R3 will only change. Let us write the others here. So minus 3, 0, 1, 0, minus 1, 0. Row 3 plus row 2. So 0 plus 0, 0, 1 minus 1 is 0, and 1 plus 0 is 1. So we have got number of zeros and 1 also. So 0, 0, 1. Here also row 3 plus row 2. So this is 1, 0, minus 1, 4, minus 3, 1. And I hope you'll be able to add these 4 minus 3 by 2 and minus 3 plus 3 by 2 and 1 plus minus 1 by 2. So let me just write it here what you are going to get. Actually it is 4 minus 3 by 2. 4 to the 8 minus 3 by 2, that is going to be 5 by 2. 5 by 2. You should only, ponder upon the logic. The calculation I hope you'll be able to do. Next one is row 1 we are changing to row 1, because we have already done row 3 plus row 2. Row 1 will change to row 1 minus row 3. So row 1 minus row 3. Okay. So we'll write this row 2 and row 3 as it is. Here also row 2 and row 3 will write it as it is. 4 minus 3, 1. 5 by 2 minus 3 by 2 and minus half. Row 1 minus row 2 will do. So row 1 minus 3 minus 0. It's going to be minus 3 only. 0 minus 1 minus 1 is 0. And 1 minus 0. Again we got a 0. Right? So row 1 minus 1 is 0, 0 minus 0 is 0, minus 3 minus 0 is of course minus 3. Same thing here on the right hand side also, row 1 minus row 3. So I am just writing it directly. It's going to be minus 3 by 2, 3 by 2, and it's going to be minus 3 by 2. Next one, since we have got many zeros but we still need minus 3 and minus 1 to be made as 1. So we are changing row 1 to row 1 multiplied by minus 1 by 3. So just multiply the first row by minus 1 by 3. So minus 3 into minus 1 by 3 is 1. The other things will remain like this. 0 minus 1, 0, 0, 0, 1. Minus 1 by 3 multiplied. So it is going to be 1, 0, 0. So again minus 1 by 3 multiplied by 3 gets cancelled. And negative will become positive. So 1 by 2 minus 1 by 2 and 1 by 2. Other things remains the same. 4 minus 3, 1. And then we have 5 by 2. Minus 3 by 2 and minus half. See, on the left hand side we have already achieved it. Almost. Only this minus 1 has to be changed to plus 1. For that We'll just change the sign of row 2. This only minus has to be made as positive. So row 2 we will change to minus row 2. That is the only thing we have to do. Okay. Row 2 will change to minus 2 plus. So I'm just changing the sign. I'm not doing that in a different, we are just short of space. So just imagine we have changed the sign. So this right hand side is A inverse. Left hand side we already made as identity element. Right hand side is A inverse. So the final value is like this. Half minus half half minus 4, 3 minus 1, 5 by 2 minus 3 by 2 and half. It will take a bit time, but you will get the result like this. This is going to be A inverse into A. Okay, these are the same type of questions. So it will take some time, but I have given you the result. So you can just go through that solution, and anywhere you are stuck, you can just take an idea. And once you are done with all these, I hope you'll be able to do the elementary row transformation. Either it is 2 by 2, either it is 3 by 3. You will be able to complete all this with this elementary row transformation. So all these are just repetitive. The numbers are only changed. Otherwise, the way the steps I actually told you, they have to be followed exactly like this. Okay, this is all about this exercise. Thank you so much. Take care of yourself.